Welcome everyone to the final episode of our drone technology series. Today we'll discuss the evolution of drone technology, tracing its journey from early remote-controlled toys to intelligent autonomous aircraft. When consumer drones first arrived, many viewed them as novel flying toys. Today they are no longer simple camera accessories. Modern drones have evolved into intelligent aerial platforms, capable of autonomous navigation, environmental assessment, and complex task execution. Today, we'll review the technical evolution of drones and examine how they continue to reshape industry and society. Tracing drone technology back to its origins reveals roots in military unmanned aerial vehicles. In the 1930s, the British Royal Air Force developed the DH-82 Queen Bee as a radio-controlled target drone. By the 1970s and 80s, military reconnaissance drones saw expanded operational deployment. Rapid advances in civil technology during the 2000s opened doors for commercialization. By the 2010s, companies like DJI and Parrot entered the market, establishing the modern commercial drone industry. Airframes became smaller, battery efficiencies increased, and consumer-grade GPS integration made aerial technology accessible worldwide. How far has civil drone technology advanced compared to early models? Let's look at key technical upgrades. First, propulsion has upgraded from high-wear brushed motors to high-output, long lifespan brushless motors. Next, power systems evolved from heavy, low-efficiency nickel batteries to intelligent LiPo batteries with self-diagnostic capabilities. Also, camera payloads transitioned from non-existent to modern systems, like the DJI Mavic 3 Pro or Inspire 3, capable of 4K HDR, 5.1K and 8K capture, using 1-inch or larger sensors with RAW support. In addition, signal transmission advanced from unreliable analog channels to high-bandwidth ones. Digital links with low-latency video streaming. Furthermore, flight controls evolved from purely manual stick inputs to automated return to home, waypoint navigation, and multi-directional obstacle avoidance. Sensors upgraded from zero internal stabilization to integrated GPS, IMU arrays, vision sensors, and AI flight algorithms. Finally, software evolved from basic hardware to integrated firmware, smartphone control, apps, and cloud telemetry synchronization. These advancements have enabled drones to expand across multiple industries. First, in media production, aerial cinematography has become an essential tool for content creation across YouTube and film industries. Next, in industrial applications, agricultural drones automate spraying and crop monitoring, while mapping drones perform complex topographical surveys. Drones also inspect hazardous infrastructure, like power towers, mines, and construction sites. Also in search and rescue, emergency services deploy drones for disaster response and missing person searches. Finally, in logistics and delivery, global corporations and regional projects actively test autonomous drone deliveries in remote and island areas. Looking ahead, drone technology is moving toward fully autonomous flight. AI systems, IoT connectivity, high-precision sensors, 5G networks, and cloud computing are converging into unified platforms. Future flight systems will feature AI-driven autonomy capable of real-time obstacle detection, dynamic path recalculation, and automated recovery without human intervention. Centimeter-level RTK positioning integrated with 3D spatial mapping will refine autonomous flight paths, continually processing cloud data mid-flight. As international regulatory frameworks for urban air mobility, or UAM, mature, dedicated low-altitude air corridors are being established worldwide. This infrastructure will enable air taxis, emergency medical transports, and integrated autonomous operations in the near future. Despite these technological strides, one fundamental principle remains: technology is ultimately a tool. How we deploy these tools depends on pilot judgment and operational responsibility. As drones become easier to fly and more intelligent, pilots must maintain discipline, safety standards, and regulatory compliance. That brings us to the conclusion of our drone technology series. This series was designed to go beyond basic hardware manuals, providing a clear understanding of aerial technology and safe operating practices. Equipped with a comprehensive understanding of these technical systems, you are ready to enjoy safe, confident flights. If you found this series helpful, please like, subscribe, and turn on notifications. See you on the next flight. Thank you.